Likewise, a tremendous disclosure made by means of the James Webb Space Telescope. City lights seen in space saw 7 trillion miles from Earth. This enormous finding has started interest in the chance of extraterrestrial life. The telescope zeroed in on Proxima Centauri b, the nearest exoplanet to Earth, uncovering noteworthy brilliant lights radiating from it. What could be the justification for these town lights on Proxima Centauri b? Could this, in the future, demonstrate the presence of life past our planetary group? As we dive into how the James Webb Space Telescope recognized these uncommon peculiarities in space, specialists and the overall population have long conjectured about the presence of life past our planetary neighborhood. Proof suggesting life has been eagerly anticipated. Indeed, the academic local area turned out to be especially remarkable when solid signs of living substances were noticed utilizing the James Webb Space Telescope. While examining space and sending vital records back to Earth, the James Webb Space Telescope distinguished visible city lights shining from the exoplanet Proxima Centauri b. These lights were precisely as their name implies, like those illuminating a city. The plausibility of an outsider city present on the star has left researchers interested and surprised, looking like the existence they have all been expecting. Assuming that this is indeed true, it suggests that there are possible living beings building advancements new to what people comprehend about space, and we are only finding it. Examining the city lights arranged 7 trillion miles from Earth, NASA architects can't resist the urge to ponder how long those lights have been noticeable in space. David Kipping, an astronomer from Columbia University, describes the Proxima Centauri b exoplanet, where the town lights were located, as fascinating. He stated this because the star system closest to us shows 4 styles, unlike other planets. The regular rocky planets are known to absorb sunlight and emit infrared radiation, but not so for this exoplanet. Its infrared nature is remarkably particular from that of its host star, named Proxima Centauri. This requires a sharp observational eye through the James Webb Space Telescope, JWST, which ended up being the best apparatus for the task. The JWST can indeed appreciate infrared frequencies, capturing the beautiful energy characteristic of Proxima b, which is a significant part in revealing the laid-out secrets of its circumstance. This could be achieved thanks to the high-level period of infrared imaging capabilities developed through the JWST. Researchers mean to apply the telescope to view as the natural components of this planet at air levels. They also plan to use the Webb telescope to explore the possibilities of life on this exoplanet. The James Webb Space Telescope has an infrared capacity that is capable of analyzing what happens on Proxima Centauri b's surface, capturing the smallest light emanations in the vast obscurity. This is generally really difficult for space telescopes, but not for the JWST, as it can detect even the smallest light emanations from space. It's the best tool to verify if the reports about city lights on Proxima b's surface are accurate. Not every artificial light in the universe can be detected using the telescope, as long as it falls within a frequency band that is often smaller than the starlight. Proxima b has an interesting relationship among its heavenly parts and surface conditions. The daytime side of the exoplanet includes different solar chargers that harness the intense solar energy produced by the star, while its spectral region reflects incoming light beams. Meanwhile, when Proxima b completes its circle around its host star, Proxima Centauri, it experiences continuous cycles like what we have on Earth, with sunshine hours having high solar power and the nighttime experiencing coolness. The planet is thought to have temperature variations controlled by its shape. For example, assuming there is no air on Proxima b, the difference between its day and nighttime cycles can be gigantic and far apart. Assuming that there is no regulating effect of atmospheric gases in seas, the daytime temperature can be burning hot, like a dim edge, and the evening will dive into cold darkness. The level of temperature variation is a significant worry for space astronomers to determine for a deeper understanding of Proxima Centauri's structure. With superior infrared imaging capacity, the JWST can indeed observe the planet's thermal emissions to provide accurate data about its environmental properties. Notably, the circle of the James Webb Space Telescope around the Earth lines up with Proxima b's orbital period, offering a comprehensive perspective on its 24-hour cycles within 11.2 Earth days. Assuming that it indeed has an environment, the subsequent step would be to determine its environmental sustainability to check if it can support life. Some quality indicators for evaluating the presence of life include gases like oxygen, water vapor, and methane. If these elements are observed on the planet, it suggests that it maintains practical circumstances for life. The task of precisely distinguishing this calls for experts to be careful as they gather and analyze light beams that go through the planet's air. This is a challenging mission, but the JWST has excellent capabilities for portraying planetary airs. It has an essential objective. The telescope has been programmed to best examine the variety in water vapor, carbon dioxide, and methane. Awareness with regard to detecting enhanced oxygen, which is a critical sign of something happening far below. The JWST is limited in this area. Although the telescope still has key motivations to search for different elements inside the planet, like ozone, which offers a unique level of significance within the air. The fact that the James Webb Space Telescope doesn't have thorough capabilities and can't peer at possibly the closest habitable worlds to Earth is leading to a comprehensive atmospheric investigation. Space astronomers are now leaning towards ground-based observatories like the Extremely Large Telescope, ELT. The ELT is a telescope designed to start operations in 2028 and is in a calculated way positioned to provide detailed observations of exoplanets like Proxima Centauri b. It will complement the capabilities of the James Webb Space Telescope by offering higher resolution imaging and the ability to conduct more in-depth air investigations. Ground-based observatories like the ELT are vital for confirming and expanding upon the findings of space telescopes. In end, the discovery of potential city lights on Proxima Centauri b by the James Webb Space Telescope represents a significant achievement in our quest to track down extraterrestrial life. This finding has generated excitement and interest among scientists and the public alike as it alludes to the possibility of advanced civic establishments existing beyond our solar system. The continuous advancements in space observation technology, combined with the efforts of both space-based and ground-based telescopes, will undoubtedly enhance how we might interpret the universe and bring us closer to answering the age-old question of whether we are alone in the universe. A more significant exploration of remote exoplanets will offer information on those planets to provide comprehensive and clear insights into their level of suitability. NASA specialists and all people are anxiously anticipating the development of future space telescopes. Until that time, however, the James Webb Space Telescope remains a critical tool in our journey to uncover the secrets of remote exoplanets. Despite its current limitations, the Webb Telescope has the capacity to provide significant insights that will revolutionize how we interpret exoplanetary studies now and in the future. Researchers have a goal for future space telescopes to reduce the amount of glaring light coming from a planet's host star, so astronomers can better see the light reflected from the exoplanet itself. They plan to achieve this using internal sunshades or large external sunshades shaped like an umbrella, like using your hand to block sunlight beams to allow you to clearly see an object. Reducing the overwhelming brightness coming from the host star will better position future telescopes to focus on faint traces of light coming from exoplanets, allowing a clear assessment of their air and the possibility of supporting life. Doing this comes with its own challenges. However, researchers want to distinguish gases involved in life processes from those resulting from geological activities like volcanic action. Astronomers are not giving up on understanding the characteristics of exoplanets, so they are better prepared to identify signs of something happening on a deeper level and distinguish them from misleading upsides. The JWST represents both a challenge and a remarkable opportunity. An intriguing story has emerged recently, suggesting that extraterrestrials may indeed be a remarkable thing within the stars, only waiting for humans to discover them. To provide an answer to this question, American space researchers Jill Tarter and Thomas Pearson launched a mission called the Search for Extraterrestrial Intelligence, SETI, in 1984. Laying out the SETI Institute, it is a non-profit organization that aims to sift through massive signals to clearly detect radio transmissions from space. The rationale for focusing on radio transmissions is their ability to travel long distances without getting scattered or absorbed like other forms of radiation. Because of this characteristic, radio transmissions are sure to be distinguished by the 42 radio telescopes that make up the Allen Telescope Array, located in the foothills of California. Although the SETI Institute has not yet identified indications of radio transmissions made by extraterrestrial life, Jill Tarter remains inspired by the possibility of a positive outcome. They plan to use the tools of the 21st century to accelerate the search. In Jill's words, "I hope that we could allow Earthlings everywhere to become active participants in the ultimate search for extraterrestrial intelligence." All of this went on until recent reports from NASA suggested that the James Webb Space Telescope discovered city lights from a planet close to Earth. The JWST is the game-changer used by humans in exploring the universe. It is currently the most advanced tool in all of humanity to reveal the secrets of the universe. The telescope is now orbiting around 1 million miles from Earth, sending precise insights concerning the earliest instances of the universe. It is expected to gather newly diffused insights about space as it delivers more data on the development of galaxies, planets, and stars. Astronomers haven't missed the opportunity to benefit from the JWST's state-of-the-art updates, including its unique digital camera component and filters to detect and analyze the delicate hues surrounding supergadgets. Scientists are eager to use the telescope to gather data about the true properties and chemical structures of celestial bodies located far away in the universe. This was achieved by isolating specific frequencies of light. Beyond observing, the Webb telescope continuously examines the atmosphere of exoplanets for faint traces of life, no matter how small. It has an incredible ability to investigate the presence of life and has discovered some of the most fascinating findings of all time, including the discovery of a mass larger than previously believed to exist in the universe. This mass has been detected in various large structures, raising questions about the early evolution and expansion of the universe. Humankind has since decided to explore the farthest reaches of the vast field using the JWST as an indispensable tool for achieving this. Through the telescope, new information about distant worlds will be recorded, and more astrophysical data will be made available, ready to address the mysteries of those planets. Many years ago, the vast space beyond our local planetary group wasn't investigated. Since then, cosmologists have analyzed more than 4,000 exoplanets that circle distant stars, demonstrating how far human ingenuity can go. Still, those discoveries are seen by NASA as just beginning to expose the cosmic iceberg. Researchers believe there are indeed trillions of exoplanets scattered throughout the universe that haven't been discovered yet. Not giving up, over time, scientists are still exploring space with the faint hope of seeing as alien environments where humans haven't wandered. They've had promising signs throughout this mission. For example, when Galileo embarked on a journey to Jupiter, its spectroscopic device accidentally revealed an intriguing spectral signature that lent hope to extraterrestrial life. This was the first time scientists found a profile indicating the presence of life in the universe. This biomarker was the vegetation red edge, VRE, which looks for extraterrestrial life specifically via carefully observing how it reflects light. With the help of the VRE, the James Webb Space Telescope is supposed to reveal the secrets of extraterrestrial environments through the careful assessment of the orbital attributes of potentially habitable planets residing within the habitable zones of their alien parent stars. Once these are identified, the VRE can provide significant confirmation in the search for intelligent living entities outside Earth, starting a new journey in uncovering the secrets of the universe. When sunlight passes through the atmospheric layers, the scattered light, which carries unique frequencies, gets absorbed by the dust and particles identified within the atmosphere. As the absorption continues, a specific spectral signature associated with unique fingerprints is formed, which can be interpreted through spectroscopic analysis. It's a common understanding that when light from stars reaches a planet, the JWST will be able to figure it out as it enters the planet's atmosphere. This data suggests that the JWST could be the missing link to disclosing the organic composition of those Earth-sized planets and planets with atmospheres rich in carbon dioxide, nitrogen, and oxygen. Such planets may possibly harbor life. However, the absence of essential compounds may indicate alternative forms of existence. Modern pollutants, such as chlorofluorocarbons, CFCs, man-made chemicals used for refrigeration and other industrial purposes, could assist scientists in proving the presence of extraterrestrial development. If the JWST identifies such synthetic debris inside the atmosphere of exoplanets, it will likely be solid evidence of extraterrestrial activity beyond our planetary system. This opens up a new window for wide scientists to examine the organic makeup of other worlds and the slim chance of extraterrestrial civilizations beyond Earth. The possibility of life far from Earth is characterized by a vast range of possibilities that go beyond the limits of conventional understanding.